Okay, we're now live on YouTube with for our third presentation of the day. So this one will be about the window transit technology and building design. We have quite the panel today, so that's really great. I want to thank again Veka as presenting a sponsor and Everlast as gold sponsor for the regional week. So on that, I'll leave you with Rick Priest, who's going to be our moderator today. So Rick, good afternoon.
Good afternoon and welcome everybody. Glad that you all tuned in. Just going to give a quick introduction. Of course, Al Ugalis needs no introduction. He's world famous in our world. Robert Rorick is owner of Graphically Speaking and also an instructor at Lethbridge College of Architectural Design. Peter Schultz is with Riddell Corsaba in Calgary, an architect, and Sathya Ramachandran is with EXP, and he is also a professional architect. So, as we said, what we're going to do today is we kind of want to see what everybody sees going on as far as trends in the window industry, and where they think that perhaps the industry might be going. So, Sathya, why don't you kick us off?
Sure. Based on our conversations, I would like to, there's several things that I could point out, but one of the things that is close to my heart is, being a building science consultant, like what Rick mentioned, that I'm a registered architect, but I do have a master's in building science. And for the last 20 years, I've been practicing building science and envelope engineering. One of the things that I come across quite often, and that it's becoming a trend here in Alberta, is the requirement of commissioning, and that's one of the things that I wanted to talk today. I know, we could be starting from the design and go backwards, but this is more or less at the end of the process for a window. So I would say commissioning is becoming a trend here in Alberta. I see quite often proposals and RFPs written written by the government bodies requiring all sorts of testing. I know the jurisdictions like Ontario, Toronto and Vancouver, they already have this in place, and it's part of the building process to be doing field testings and such. Not so much in the prairie regions. Since my start of practice, here in prairie regions, I've seen here and there field testing happening, depending on the owner's appetite and so on and so forth. But certainly, that's a direction the window industry should be. That's the direction that the construction industry is going, and I would say the window industry should be more prepared for it. I guess I'll start there, and I'll leave the topic there, and then I guess we can have a conversation about it. About other things in terms of trend.
One question I would have, Sathya, is you'd mentioned that it is creeping in with the government agencies, and I've certainly seen that with some of the quotes I've taken a look at from Alberta Infrastructures as an example. Are you starting to see cases of that in private industry as well, or right now is it still mostly government type contracts?
Some of the there's also a push from the consulting side of things, and asking for these verification testing. Architects being architects having that knowledge of serving to the public bodies and also serving the private bodies. The more and more I see the specs are including the testings, field testings, and such. And it does come down to the appetite of the owners, and I have seen the owner builder are more receptive. Sorry, the owners who who will be managing their buildings in the long term do have the interest of ensuring that their systems are performing. Some examples I could say are seniors housing. There have been, like, I've been involved in a few seniors housing projects, more private organizations that have requested to have these windows tested. In fact, like, I do have one owner where that had to go through a full replacement of windows in a relatively newly constructed building, I would say within 5 years and so on. There have been some challenges with Windows, and they did in the future projects that we are involved in, they insist that, like, these tests to be conducted as part of the construction activity. So yes, to answer your question, yes, not so much with the developer builder type clients so far. So
Thank you. Okay, who's next? We'll pick on Rob next.
From a trend perspective, from my end of the world, I guess what I mostly see is obviously residential design trends, in which we have a little less input as far as product goes. Ultimately, that ends up in the lap of the contractor typically, but suggestions for sizing, coloring, styling, fenestration, and that sort of thing is fairly typical for what we do. We're seeing a lot more, and this has been kind of an ongoing trend over the last, I want to say, decade or so, of the open space condo-esque sort of environment that people are looking for in home design. And of course, along with that comes lots of light. They want to be light and airy and give that ethereal feel. And then of course along comes the challenges that the energy code requirements kind of inflict, if you will, or impose on those designs. So we have to be very, very conscious of how much glazing and where glazing is located and those sorts of things. And of course, on larger scale projects, whether commercial, whether it's multi-family units, we have very similar issues to consider. And then, of course, once you get into multifamily, then you develop the whole, your fire code and those sorts of things step in and really impact it. And of course, people like Satya and Peter would have a much better handle on those sorts of things. But there are always considerations that we have to make. And of course, I've done design up to and including 20 suite units with professional involvement, of course. And it's always more is better from the client perspective, and less is better from the builder and the energy requirements perspective. So it's that kind of balance that we're trying to create. And but the trend, I think, is always going towards more. So we're trying to create a balance in there between what we're required to do and what people want to do.
Could I ask a question, Rob?
Right.
Please.
With respect to larger glass areas, potentially you could address the energy requirement by using a more energy efficient window. Let's say you might have to go to triple glazing, but then you might be able to get that higher window to wall area from an energy point of view.
Yeah.
Do people value the extra glass area enough to be willing to consider a more expensive product, or does that budget kick in and they stick with a smaller window?
That's that whole budget / requirement / the needs and wants, right? We always go in and fight that. That's always a clash between needs and wants and what they can get away with from the builder perspective, obviously. But I always encourage, if they want that, then I always encourage. We do some building modeling for energy requirements. We don't always do everything on a prescriptive basis. So we do some modeling, and we can do some trade-offs, of course, with our HVAC systems and those sorts of things, and minimizing our exposure on, for example, the north side of the home, or those sorts of things. But of course, our lot kind of restricts where we are in subdivisions. If you're on one side of the street versus the other, you've got the opposite problem, right? But yeah, I always encourage, if we can, to go to an upgraded window. I always prefer a better window, just from the fact of performance. So whether it's depending on the manufacturer that we've got available to us within the budget constraints that we've got, I always like to, because that's something, like Satya said, that having to replace all those windows in that seniors complex, that's the last thing I want my clients to have to do 5 years down the road. So I always encourage them to go with better infrastructure, as it were, on their home. And I said, you can replace your flooring in 5 years and not feel badly about it, or your countertops or what have you, but you don't want to have to replace your windows or your roofing or those sorts of things. So I always encourage a better quality or a better standard of fenestration for my clients where I can do that.
Do you use HOT 2000 for your energy modeling?
The fellow that I use does, yes.
Okay.
I keep toying with the idea of getting involved with that, but I don't know what the ramifications are and all that. So,
and under the codes you work under, is the performance of the building evaluated, or
yes,
yes,
as a whole, yeah. It's everything from HVAC through our unprotected openings and wall construction and all those sorts of things, right from the roof right down to the foundation. So it's all included in that modeling, because they're trying, of course, the modeling, we're trying to squeeze out as much as we can to allow us to do things like large areas of glazing and that sort of thing. And that's typically why we go to the modeling and stray away from the prescriptive. Because on typical housing, prescriptive is more than adequate. But if we get into some atypical situations, then we like to use the modeling, because it just gives us that flexibility. And if we can adjust an HVAC system to account for whatever they need, then lots of times that's a better or more cost-effective option than going to a higher performance glazing, for example.
If I may, we have a question here.
Yeah.
So someone's asking, so interesting thread to note about the verification and field tests. I understand this is common with MEP products, but when it comes to fenestration products, they already are tested for thermal and NAFs by an accredited third-party lab. How does that weigh in versus what the owners / consultant need? Is it as good an acceptance as field test?
So I guess I think that question is sort of directed to me, I guess. So I'll take that first stab at it. So we know that, like, the windows being supplied are supposed to meet the NAFS requirements in terms of lab testing. However, there are a few other items that we need to consider. There's like the handling of the product as it is being shipped, and then the verification of the product against a sample that is tested in the lab. I mean, there is like gray area starting from the lab testing. I mean, a certain manufacturer's product of a certain series, of a certain size and such, is being tested in a lab. And to some extent, we can, as consultant owners, we can rely on that testing. And also there is labeling that we could be relying on. Having said all that, we certainly do have some more challenges in terms of like the handling of the product, and installation of the product is a big one. And during the field testing, it is one of the items that we also verify. checking the interface details along with the window system itself. Quite often, we do notice that like there are some significant changes between the sample that is tested in a lab versus what is supplied. Sometimes we also notice that the window supplied, probably the size of the window that's being installed in a building is slightly larger than what is tested, and so on and so forth. So and then there's combination composite windows, and so on and so forth that we need to be aware of. So there are some gray areas in spite of us testing in the lab. There's some that we can capture at the time of the field testing, and there's where the value is for the field testing. So I hope that answers the question. And if other panelists want to add to it, I would appreciate it.
I think you really hit an important point there with the verification of the installation.
That's right.
And that's critical, because all the testing in the world on a product can be laid to waste by poor installation. So that on-site testing, I think that's probably as key a component of that as there is.
There's also the manufacturing.
I'm kind of curious, Satya. I mean, it sounds like you have some experience with field testing. What do you see in the field? Like, what percentage of the time do you think it's an installation problem versus workmanship versus product design? Any idea?
I can speak to, I don't maintain a statistics per se. However, from the limited, while I was practicing in BC, I would have tested like hundreds of windows and window wall systems and curtain wall systems. Whereas in Prairies, it's like I mentioned in at the onset, it's not a quite rigorous. It's not part of the construction activity as common. So the amount of testing that we have done is limited. Having said that, it's significant that I can kind of relate to what I've seen. One of the few common issues that we have seen is it is both. To answer your question, it is both the window system and the interface where the failure has happened. Number one, for the window system, some of the common, like I could give you some example, the setting blocks being on the way of a heel bead, not necessarily providing your seal for an interior glazed window system. That is a quite commonly observed failure. And sometimes, the water dust, in an exterior sealed windows too, like, there is water track filling and then escaping through the interior weather seal. Those are the common ones as far as the window system goes. For interface, like, it's more often carelessness is what I would say, because when we are involved as building science consultants, we do mock-ups and we do periodic reviews of these installations. And during the mock-ups, like, we do make sure that like the interface is done right, and we test the mock-up to make sure that the design of the interface does work. And during our regular periodic reviews, like we handle that like by comparing it with the mock-ups and so on and so forth. Where I have seen like some failures is like, for instance, a window was installed and a screw hole was left behind without patching it. We have seen water coming through those screw holes because we are depressurizing across the assembly, and so on and so forth. So I would say, like, when a building envelope consultant is involved and doing a mock-up and a regular periodic review, the interface detailing has been limited. So I would say, like, the first test, I haven't gone back to do that statistics again. In the first 3 years, we would have tested like 10, as an example, 10 vinyl windows, out of which, like, 8 to 9 had failed. I would say, like, I even say I'm being moderate, like 9 windows failed, and out of which, like, 8 of them were to do with something or the other with the window system itself. But I don't want to give that as a statistics, but it just so happened for in our case, like when we tested those first 10 windows. So I used that as a some quantification of what we experienced in the first 2 years of my presence here in the Prairie region. But otherwise, like, I don't have the statistics overall.
We have Aaron mentioning. We have her mentioning field testing results 75-90% Windows system. I don't know if it's related to what you were saying, right?
That's right. Yeah.
And then he mentions due to 70-80% manufacturer issue, 20-30% window design issue. That's his take on it.
So is that a quality
you.
control issue typically?
Yeah, I would say quality control, especially that heel bead. We all know that the heel bead has to be continuous. I'm just quoting one example here. I mean, sort of, I'm expecting the design could have handled it a little bit to allow for the continuous heel bead as well, like by having that setting block placed in the right place. But if the other windows are passing and these particular windows that are failing are because of that situation, I think the quality of installation could have been slightly better on those windows that failed.
Okay,
One of
Peter,
the
you've been a
things-
little bit quiet.
Huh?
Oh, I'm sorry, Al.
No. Well, one of the things that manufacturers in BC have noticed, some manufacturers think, you make a window, you test, bring it to the lab, you test it. You might have failed your first water test. You tweak your hardware, you adjust it, you make sure your gasket joints are sealed. Now you pass the test. And that's great. You've got the test, but that level of quality management doesn't always carry through to every product on the assembly line. So, 2 years later, you haven't tested any windows in 2 years. You might have had changed the gasket you were using. You've got new people working on the machinery. They weren't involved in the testing. If you're not doing regular quality testing of properties like water penetration, you risk having a problem where you deliver a whole bunch of windows to the site and there are problems. So the manufacturers that regularly serve the large building market in BC all have internal test walls and they do routine quality testing because water is very sensitive to workmanship issues, and even the tolerances of parts you receive from your suppliers can influence that. You, for example, might have developed a product with a certain gasket and all of a sudden you start failing water tests, and it's because the gasket is of a different tolerance dimension. And it might even be within the acceptable tolerances of the gasket extruder, but it's not an acceptable tolerance to your product. So these are the kinds of things that can happen even outside the manufacturer's control. So when you have critically important performance properties, that are being tested on the job site, the manufacturers learn to which things to monitor in their process. But if you're coming from just the residential market where there's no testing, or if you're in a market like the Prairies where field testing isn't common, then it can happen that even manufacturers that are trying to do a good job and manage their products properly, they may still not be managing closely enough the properties that are significant to reliably pass a water test after it's been handled, after it's been installed, and it still has those properties. So I think I think the manufacturers that start to encounter these problems learn to adapt to it, because as you could probably tell us, Satya, if you start having window failures on a job site, what do you do?
Yeah, good one.
What's the next step?
That's right.
Test
So
more windows, right?
yeah,
So,
that's exactly right. So the rule of thumb, of course, this may be a news to many of the manufacturers in Prairies, is that the rule of thumb commonly accepted in the industry is that, like, if one window fails, you have to fix that window. First of all, investigate and find what the cause of it and provide a remediation plan and do the remediation and test it to make it pass, followed by additional 2 windows of the same size and configuration to confirm that this is not a systemic issue. And if the remediation does require a systemic remediation, if the remediation is systemic, then you're on the hook to be fixing it in all the windows across the, like in the entire building. So that's and more you will notice that the specifications will include field testing qualification requirements, in addition to who's responsible for what in terms of the cost. So the initial test being the cost carried by the owner, the additional test, like whether it is the window that failed, the system that failed, or the additional 2 tests will typically fall on the contractor / trades and / manufacturers and so on. So that's
Okay.
I would expect. I mean, this is coming basically from BC and Ontario jurisdictions. So I would say, like, Al, nothing has changed in BC, I guess, right?
No, you know, and I think sometimes they might want to test more than 2 extra windows, but if you test 2 more and 1 or 2 of them fail, then what happens?
You continue to
Then you keep
do the same.
testing, and pretty soon it becomes very expensive. You know, and that's where manufacturers quickly learn it's better to prevent that problem than to encounter it. So
Yeah.
We have.
So
we-
I can give you an sorry.
No, it's okay. It's
just
just
to
we have
go-
some comments. You can go ahead.
Yeah, just to wrap, I mean, we have had instances where both in BC market here in Alberta, where it went to a stage where we cannot make these systems pass, and you know, at that time, like, the manufacturers had to take it upon themselves and come up with this remediation plan, and also do more tests to prove that it will work with us witnessing, and so on and so forth. I mean, there have been instances where we even bring in a third-party consulting firm to be the witness, because it becomes like contention at that point, and we need. I mean, it goes to the. It's not there yet with the lawyers, but it is almost there with it, because we are involving more than the building envelope consultant, the architect, and the window manufacturer at this stage. So.
Okay, so we do have a couple comments and questions. If you don't mind, I'll go with that. So we have Terry saying, interesting failure rate. I would say all the site tests I've attended, the window failures could often be related to poor install, sills not level, weather seals contaminated with construction debris, etc. Then you have Dave asking, have you seen failures of the windows themselves, not the installation, that could have caused damage to the envelope or to the interior finishings?
I just came back from window testing that's happening right now for a. I mean, this is not a multifamily; it's a single-family, high-end building where it's a metal-clad wood window, where they're right now testing to see how these windows are performing. To answer that question, yes, Dave, we have seen windows that does leak during testing, or like during its performance through its life cycle, and also when testing we see the water coming into the interior drywall and causing damage. Yes.
Okay.
I mean, this is an example. Not as much with vinyl windows, maybe not as bad, but with this particular window that we just witnessed, like, yeah, it does happen.
Okay. Then we have Terry just mentioning always attend site test of your products. So just as 2 cents on that. And we have another question for you, Satya, and then I guess we'll move with you, Rick, for the rest of the presentation. But so the question is, site test conditions and lab test conditions are never the same. There will always be a variance, but shouldn't be to the extent of the system failure. So what's the acceptable tolerance in field test results versus lab test results?
I mean, I know like where this is coming. It's probably the AMA testing standards do allow for certain reduction of pressure differential in US, which is not the case here in Canada. So we still follow the Canadian supplement of the NAF standard to decide on what performance rating we are looking for on these windows. It's the final product that we need, that the owners are buying into, and its performance that is directly related to the climatic condition and the articulation, and or the height of the building and where the window is located and so on. So there's really no standardized way of reducing the performance rating in a field testing versus a lab testing.
Okay.
In Canada. No.
I'd just like to chip in there for a second if I could. Being involved with a lot of window designs, particularly in my time with Veka, we certainly found, and especially in BC where they started off all the water testing out there, that if we wanted to hit 300 pascals water pressure in the field without too much problem, we would actually test the product to 400 pascals, because we already knew that there's going to be some issues perhaps with workmanship, installation, out of level, out of plumb windows. It does affect the drainage. So just, some advice, if you have to be a solid 300 pascals in the field and that's what they're looking for, make sure your product is designed just a little bit better than that. You don't necessarily have to go up to 400, but make sure you got a good solid, you're not just barely hitting that 300 pascals, because then you are inviting problems in the field. So anyways, Peter, you've been awfully quiet down there. I'm kind of scared you're going to fall asleep on us. So
No.
you sure had a lot to say in our pre-meeting. So I think it's
Yes.
your turn. You've been very
Yeah,
patient. Thank you.
I just want to start with a comment that I heard yesterday from the BC regional saying that, oh, tomorrow we go to the prairies and there's snow already on the ground probably. So I have to disappoint those folks. We have a beautiful fall right now, a golden fall with 20 degrees steady for the next 1.5 weeks. So that's pretty beautiful. That's unique for us at the moment, and we really enjoy that. So
I know it's missing rain in Vancouver, right, Peter?
well, yeah. So, and again, I don't mention, the solar gains we have in Alberta. I mean, 300 hours of sunshine in Calgary. So that's pretty nice. I mean, it is getting cold, and cold climate design is incredible, interesting, but we have also benefits. So from a trend perspective, I think as an architect, what we would like to always achieve is buildings that are utmost comfortable for the user. And that's not only from the perspective of, temperature and humidity, but also, of course, from the well-being standpoint. And I know windows are obviously a weak point in the envelope. We are pretty much capable nowadays to create super dense envelopes with high insulation values. But the windows, obviously, there is always that's kind of the crux of things. But I see that the standard that we have and the path that we're going, and Al was alluding to the fact on the roadmap this morning that the gold standard of a U value of 0.8 is where things need to go. So we as architects, we always want to assure we have a variety of products that we can choose, that we contribute to the energy saving need. There is no question, I don't think, for anybody to agree that we need to save energy and conserve energy as much as we can. And the third items I would recall is, we need to assure windows are functional, they are flexible, and they are durable. I think those three are utmost critical. Functional in a sense of, we have different applications. Sometimes we don't want to have a window that is operable or whatever. And flexible, I would allude to the fact that as architects, obviously, we are interested in designing buildings and orienting buildings to the, quadrants of the sun, what do you call it? Sun rotation. And sometimes we cannot, because the obviously city planning and stuff predicts where we have to go, which is kind of contradictory. Or even in older cities, you're deemed to live with what you have. And then from a durable perspective, as we know, the product can be as good as it can be, and then failure maybe during transportation or installation issues could cause issues for a long time until they are detected. So I think that's the utmost critical aspects, I would think, from an architect or design perspective. And then I think last time we talked about, what do we see as trends? And obviously I think I highlighted the importance that daylight does to our well-being, or views into landscapes and other things due to our well-being and performance within a building, be it an office building or a residential building. But I think we have to find the balance of what we can do, what can we allow from a rational perspective, what can we allow with the technology that we have available to achieve that. So I would never stretch, let's say, the boundary of designing something that is irrational and is not contributing to the goals that we just discussed, right? I believe that we have nowadays products that are really good. We have products that are flexible in a sense of, we could introduce different glazing specs on different oriented facades. I think that is very good. If I look to the trends and research that has been done mostly in Europe, Scandinavia, I see incredible research on reducing the frame size of windows to, I think currently we probably have 30% of the window surface, or the window as a total is occupied by the frame. And I see that there's research that gets that value down to 10%. And I've seen, and I would call it, I don't know how I call it. I don't even know if we would determine what I'm thinking at the moment still as a window in a sense. But what I've seen is there is very experiments with placing like glazing, allowing for the full optimal performance of the glazing, the benefits that it does for solar gains, and then placing it into let's call it a wood block that is integrated into the facade itself. And so you eliminate almost the typical or the traditional framing, and that the U value on those is incredibly low as well. So I've seen that. I've seen when we talk about thin frames or reduced frames, I see that the frames get added into depth. For example, in a country like Denmark, they often have 150 millimeter insulation. And I've seen a window type that is so thin in the frame, but it's very deep in the in its extent. So it extends almost the 150 millimeter within that insulation cavity, and then has a double and a single glazing element. So I think where the journey could go on fenestration, on glazing, on everything is quite open right now. And I would encourage the industry to, definitely go the way and create or be flexible to those trends.
Peter, you mentioned something interesting about, if I understood correctly, you were referring to window frames that were in effect hidden inside the wall, so that you just had the wall and then glass.
Yeah.
Would these have been passive house buildings or not necessarily?
I don't think so. I've only seen sections and write-ups in that research paper. I don't think they referred necessarily to passive house standards, but I thought the U value would go to even 0.5. I think I read that, and it was just a simple wood block, so it wasn't even any specific material touching the glazing itself in that frame.
I see.
But then you have the full performance value of the glazing, right? Sometimes, you want to increase that value of the gains that you can have without the frame, let's call it. But
one of the trends in passive house window design, what we're finding is the weakest part of the window is the frame. And so when you have a lot of exterior insulation, I know that in some of the passive house buildings being built in Canada, they're trying to over-insulate, carry the insulation over the window frame.
Yeah.
And I've seen some designs of European product where the actual window frame was designed not to be visible on the outside, where it was really designed to be covered over by the wall insulation, so that you still have an operable window. It still functions as an operable or a fixed window from the inside, but from the outside, as you say, you're seeing primarily just the glass. And and I think it sounds like that's something, the kind of approach you're talking about.
Yes, yeah, and from an aesthetic perspective, it can be quite interesting as well.
It is, and you know, I'm hopeful that we will, as we start to design these more energy efficient buildings, that it can change our paradigm of what a window is completely. Because right now, the window frame to an architect is part of the aesthetics of the building, and we play with the window frame as a kind of pattern language, you know. But when you start going to really low energy use, there are advantages now in removing the mullions, hiding the window frames in the walls, and potentially now you can have a different paradigm for thinking about how to design the window and install it.
Yes.
I think that's a very exciting area for that we'll probably be seeing some developments in the next 10 years or so. I'm certainly hopeful that we will.
Yeah. And it could necessarily also maybe reduce cost. And I'm not saying that that is a solution maybe for the overall building intent, but it could be partially used, you know, like we have to find that balance from an aesthetic perspective and functional again. And the other one that I think I read about was interesting, that there's a window in research, or I don't know if I think there's a prototype of a window that has, call it a flexible U value, believe it or not. So it's not the window that fits all, but it has a window that allows the most efficient gain. Obviously, we know low U value windows in the opposite of solar gain can cause the overheating issue. And there was a window that addresses the issue by adding a ventilation between a double pane and a single pane on the inside. And I found that very interesting. I'm not sure if that is a prototype that exists, but I thought that's quite stunning. Because we all know it's, you know, the window is not the perfect entity, because it, you know, what changes around the window during a day, right? And a night, and climatic conditions and all that. The other thing that I think, you know, when we talk about cold climate design, and I think about alpine architecture. When you look at old, you know, alpine architecture in Austria, for example, you will not find an old building being 150 or 200 years old without window cladding, as stupid as that sounds. But in cold climate design, isn't it, or wouldn't it be interesting to have an opportunity? You know, we have blizzards, or we have cold nights with -38 and north wind, to have an opportunity or an integration of something like that. Wouldn't that be an enormous energy saving?
Could you clarify what you mean by the cladding?
Yeah, like the protection of the glazing in a general sense from climatic conditions. But, and again, in the Austrian or whatever you take, alpine regions, these are wood. But I'm talking about, isn't there an opportunity to have an insulated cladding type or shutter type that you could introduce, you know? And again, of course, from an aesthetic perspective, it has to be an element. Maybe it's part of the facade, you know, in a design, or it is an invisible element that can be, you know, that can prevent the window being exposed at night, for example, to climatic conditions.
So you're thinking something like a thermal shutter?
Yeah.
Yeah. Something that could close over the window at night.
Yes, and has an insulation value that sits on the glazing.
Open during the day, right? Yeah. Interesting thought, definitely.
So we do have some comments and questions, if you don't mind. Did you have anything to add? Sorry.
Yeah, I just wanted to also add one more thought. In fact, Peter brought up during our internal conversation was about the operable units being an important element in window design or windows. when we talk about passive house and the energy efficiency requirements and going towards net zero and so on, we focus quite a bit on insulating our wall systems and our building envelope, which in turn has caused some other issues like overheating of spaces and so on. So two important elements that we need to keep in mind are the operable windows and the solar shades. Like these are the passive means of reducing the overheating for buildings that are not cooled. So just wanted to throw it out there.
Okay, so we have Brad just saying here, I think he just went back to the a couple minutes ago, but NAFS, he says that NAFS reads, the standard specification is applicable for use in testing and rating windows, doors, secondary storm product, blah, blah, blah. It represents the continuing development of an internationally accepted performance standard specification for all windows, doors, SSPs, TDDs, roof windows, unit skylights. The testing provisions of the standard applies to laboratory testing only. So I think it's going back to a couple minutes ago, right? Just as a specification. And Terry says that, right now everyone is building deeper frames to accommodate triples. It's a trend that he sees going for the deeper frame systems. He's asking, do you think this may see change as the possibility of vacuum or thin triple glazing gains traction?
Can you repeat the last part, or maybe I'll talk to you.
So the first comment that there is, I probably have to review this NAFS, the clause that is included in there to clarify that. So I really don't have an answer right off the bat.
So maybe just I'm just gonna invite, like, if Brad wants to come in and specify precise his thought, like we can have him come in live. So you can go ahead, Seth, here, like in the meantime.
No, like I'll wait for him to connect. So until then, like probably we can.
I'll see if he
maybe
can.
Peter can answer the next one. Meanwhile.
Yeah, I don't know in regards to the vacuum and the what is in between the glazing. I mean, there's also immense research being done on what's next, right? I mean, I don't think there's an end in experimenting on those things, and I don't know the name of the I don't remember the name, but there's something in that regards in exploration that is also adding an incredible value.
So we'll see if Brad wants to join. I sent the invite, and maybe we'll get back to that. So I'll give him a couple seconds here, but
yeah,
I don't want to push him online while he doesn't expect it. Okay.
Just a question for some of the fellas. Are we talking primarily about unit windows? Or are we talking about curtain wall? Or are we talking about both in these cases? Specifically, Satya and Peter.
Generally talking about unit windows still.
Yeah.
Yeah.
Okay.
So we have Brad on the line now.
Yeah.
Sure. Good morning, everybody. Actually, I'm sorry. Yeah, I think I was just trying to point out that the NAF standard, of course, the 2017 version, and Stefan had read the document there. That just basically provides a scope. It's meant for laboratory testing results only. So in the US, if you go into the NAF document, it references AMAS 502, which is a testing standard that typically tests at 2/3 of the rated product. So if it was a PG50, you take 2/3 of that PG50, and that's how you test it, both structurally and water performance. In Canada, of course, there's no reference to 502, so it's a little bit more challenging that way. But there are some reductions. If you take a look at a specific window and it's rated at DP50 or PG50, more likely than not, that's overrated for whatever the particular jurisdiction is requiring in the NBC. building code. So there's options there to test at a lower number that's required for that jurisdiction. So that's my question: is when Safa, you mentioned that you test to you don't test to the 502 standard, but you test to what the laboratory testing is. Are you testing to what the jurisdiction requires based on the wind loading and water, wind-driven rain and water, or are you testing to some number below that?
No, we are testing to the wind-driven rain. I mean, as per the NBC, that's basically what we're testing against. Yeah.
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 So
We're not lowering. I mean, like you said, the Canadian supplement. It's like you pointed out, like there is a reference to the AMA in the NAFs, but for the Canadian supplement, like we don't have such references. And I know it is one of the items that's constantly discussed based on what Greg Hildebrand, who's actually the co-chair for the NAFs, who's also a colleague of mine, indicates is that there's no reduction requirement for, or like there's no reduction indication in the Canadian supplement. So.
Right. We have talked about potentially writing a similar document within the CSA organization, or even maybe Fenestration Canada, but that
right.
Move forward yet.
Yeah, it's a discussion in progress as far as I am concerned. At this point, like we're testing it to the requirements. Whatever is being tested in the lab is how we are testing it in the field.
But really, the question isn't so much about lab versus field. The Canadian supplement is telling you what is the level of water penetration do I need at this building for the environment that it's in. So the environment requires, let's say, 330 pascals. You don't want a window that can't handle what the environment's going to throw at it.
Exactly.
So if you want to downrate the lab test rating by 2/3, the architect would then just increase the water test pressure by double, right? Okay, I need 600 PSF, 600 Pascal lab tested pressure, so you can test on site at 300 or 2/3 of that. You know what I mean? You basically, in the States, you don't have a Canadian supplement methodology to tell you what level of water penetration you need. So you're in a position to try and negotiate, I guess, with the consultants, and the AMA standard is saying, hey, be fair to the window product. It's going to have a hard life from the factory to the hole in the wall. And so you can't expect it to perform the way it did in the lab. Fair enough. But the point is, in Canada, we say, we don't care what you tested at in the lab. What we want is a window that on site will perform at the level required by the environment. That's what we want. That's what the specs say. Now, if you can't guarantee that in a field test, then you have to supply a product that has been tested to, a higher rating so that 2/3 of it will hit the level that's required at the building. So I think there's it's a difference in how we approach this in Canada versus the US, and it's not a question about is it fair or not to the product. Speaking about Canadian manufacturers, there's a lot of manufacturers who have products that will handle that pressure rating in the NAFS test and in the field. So it's not like it's not doable.
Yeah, I don't. My point though was, I think you maybe misspoke there, Safa, is that you're not testing to the labs what the rated product is during the lab testing.
Yeah. So that's where I think Al has clarified that. I mean, I just wanted to keep it brief to mention that this is the same requirement. I mean, really, like it is the environment that we are testing for. I guess that I mentioned that before, but anyway, I just wanted to keep it simple. So I basically said it is the same testing requirement. Yeah.
All right. Thank you.
Yeah. So
Okay.
I mean, in other words, I can mention it in a different way. When it's quite common for the manufacturers to present to the industry that this is tested per NAFs in the lab, and that's all you need. But again, like your system could be tested, like, in the lab, your system could have tested for 600 Pascal, whereas like the project site only requires 260 or 300 and so on and so forth, right? I know when I mentioned that, like I thought, I was thinking about it as I was mentioning it. So I think Al pointed out to the requirement of the environment for those windows. So I think that's where it comes down to when we are testing in the field.
Yeah, and I agree with it.
Yeah.
Thank you. Thanks, Brad, for coming in. Do you have anything else to add?
Not at this time.
Okay, well, thanks. We'll move with other questions here. Just give me a second. Site test pressures can sometimes not be related to the lab testing on the or the location, so much so that we see one pressure for windows and a different pressure for doors / patio doors on same elevation. Seems these value may be somewhat arbitrary. What do you guys think of that?
So I am aware of a standard that's being developed for patio doors in particular, especially the ones with, I mean, what in US they call ADA compliant, or the wheelchair access doors and such. There is, I'm not sure if it is done yet, but I know that there is a standard that's being developed to reduce the rating requirement for these doors, for the special doors. But again, like, they're also looking into what the overhang is for those doors, and what kind of protection that is available for doors, and so on and so forth. So if that answered the question, but yeah.
Good. So
I have, if I could comment to that.
Yeah.
I know that some specifiers in BC have downgraded their expectations of patio doors because they know they can't achieve the level required by the Canadian supplement, and the builder doesn't want to pay for some exotic product that'll have 400 pascals. So that's why specs sometimes give patio doors a lower standard, knowing that they're not likely going to perform to a higher standard reliably. And they can rationalize that sometimes by saying, well, there's balconies there anyway, providing some shading from rainwater. So, that'll be good enough. Interestingly enough, the 2015 National Code and that would say be the 2019 Alberta Code doesn't let you do that. It basically requires you to specify the water penetration resistance for all products, whether it's curtain wall, window wall, patio doors, windows, using the Canadian supplement. It's very clear about that. That's how you set the water penetration level for all products. Right now, what you see in BC is that some specifiers will say the curtain wall is 730, the windows are 400, and the patio doors are 300, and they're all on the same floor. And the thinking is, well, the curtain wall, if it's built right, it should do 700. So we're going to test it to 700, and the windows require 400. There will be 400, and we're going to give the patio doors a pass because we haven't seen them failing catastrophically, and they can't do it. And so that's kind of been happening in the BC marketplace. And it's interesting to me that the National Code, in the 2015 code, they've actually laid out very clearly that all products should hit that level of the specified by the Canadian supplement.
Okay.
So don't overrate, don't underrate.
Oh, would that be a median or a mean of those different products that they're specifying?
No, it's based on the environment. It's based on the height, on the location of the building, and on the driving rain wind pressure. So, that could vary. A building in Calgary will be different than one in Vancouver, different than one in Kelowna, right? So it's an environmentally determined characteristic.
Okay. So we're pretty much done here. We're gonna have to wrap this up in a little time here. So I don't know, Rick, is there anything else you guys wanted to discuss before we leave?
Yeah, there is just one thing that we kind of touched on the last time, and I think it's interesting for our members.
Sure.
We discussed a little bit on the COVID and what's going on there, particularly with the schools. And we see more and more places now in news reports coming out that they're concerned about the air quality in the schools because there's not enough ventilation. And I'm wondering, do you guys see an increased trend in providing more ventilation in those types of areas, or do you see it being addressed more with air exchange units?
I think it goes back to code climate design again. I mean, cross ventilation, for example, in Alberta is not part of the consideration. So that's difficult to achieve. Although, again, from a holistic perspective, I think flushing out a room by opening the window is the most efficient way, and that's what they, I think, allude to, that, you know, the 5-minute flushing out and exchanging the air through natural ventilation is probably the most desired, even if it's cold, but I think it's most efficient. And I don't know if you guys, but I do remember at school a long time ago, we had those opportunities in breaks that the room was always flushed out with fresh air, and it was so helpful.
Yeah, we have done quite a number of school projects locally here in Calgary, and it's not a new trend, but typically Calgary Board of Education do have hopper windows in their window systems. I mean, it could be more, but they do have operable windows as part of their requirement.
The new requirements, call it,
yeah. Yeah, I mean, for a period they didn't give too much of an attention to it, but you know, we've been involved since 2010s, and and we have seen, you know, like the requirement for operable windows as part of the design process. Yeah. So
yeah, but we know a couple.
I mean, they, you know, older buildings, they even like the buildings with wood windows and such, they just nail these operable units and, you know, not make it non-operable for safety reasons and so on. But as part of the restoration and new construction, they certainly include operable windows as part of their design requirement. Yeah.
Peter,
Okay, so
you had a comment, Peter?
Yeah, I was just, last time we also talked about some of the older school buildings, and again, being deficient in not only daylight, but even like the amount of windows currently, or because of the juggle of putting classrooms in areas where they shouldn't be. But I mean, that needs to be rectified, I think, in the future, but the new buildings are obviously having operable windows.
okay, so thank you guys. You know, I'm really happy that we were able to have you all together today. So I think we're going to wrap this up, and we'll see some of you back. So I hope we'll see all of you attending back for the next session, which is on the roles of architects and engineers in non-exempt buildings. So we're gonna add new people to the panel, but we're gonna have I think Peter, you're gonna stay with us for this next one as a last minute addition. So that's great. Just want to thank our sponsors again. So Veka for being presenting sponsor, and Everlast as a gold sponsor. So see you in a couple minutes. And
so do we leave this meeting and then go back in?
Yeah, you'll get another link. So see you in a couple minutes, and enjoy your break.
And
Thanks,
a big
guys.
thank you to thanks to all the panelists. You guys have been wonderful, stepping up and volunteering your time, and your information was very valuable to our members, and we hope to see you all again. Thank you.
Thank you.
Thank you. Thanks, everyone.